So the state of our game is currently the ball. We have two paddles. The ball is moving, and when the ball hits the top and bottom walls and the side walls, it bounces around the screen um, and changes its direction. So now we want to make it so that the ball will bounce off the paddle. And the idea behind it is that you want to make the ball change directions if and change directions on the x-axis, right? Not the y-axis. Change directions on the x-axis if it is within this y value and this y value. So if it's in between these two y values and the x position puts the ball right here on the paddle, then we want the ball to change directions on the x-axis. The same thing's happening over here for paddle 2. In between the top of the paddle and the bottom of the paddle, and with the x-axis, with the x position of the ball at the same as the x position of the left paddle. So it's a two-part problem. First, it's how do we get it? How do we check if the ball's within this range, this y position and this y position? And then we'll check where it lies on the x position. So if we look at our code, this code here is how we get the ball to bounce off of the walls, right? So this is the top and bottom wall. This is the left and right wall. So we're going to remove this, and we're going to replace it with code that's going to make it bounce off the paddle. Right? But for now, let's just leave it there. And so how do we make code to bounce off the paddle? Well, we're just going to add another if statement, right? So if what? Well, if the ball rect dot y is less than the paddles, um, or I'm sorry, what is the paddle? The paddle is the y, right? So the left one is y. Okay. And so I guess one thing to talk about before I get into the actual conditional statement is if I want to find a range of numbers, right? If a value is within a range of numbers, how do I do it? Well, to take you back to elementary school, let's say I want to find between -3 and +2, right? And I want all of the values between them. So I want these. So I want to check if a value is between those two guys. How do we do it? Well, the way you do it is you have two inequalities, right? So you have if x is greater than -3, right? And x is less than +2. So then x is less than +2 gets you all of these values. And then x is greater than -3 gives you all of these values here. So both of those conditions, both of those inequalities put together gives you these values here, the ones that are in between, right? And of course, we could have said less than or equal to, to include the endpoints -3 and +2. So that's the same idea that we're going to use when coding the ball being in between the top of the paddle and the bottom of the paddle. So we're using y as the top of the paddle. That's what I'm using. You might be using a different variable, name a different variable. So what am I checking? I'm checking if the ball's rex y, that's the top of the ball, right? Alternatively, I could have said top, ball.top, is less than the y. This is the paddle's y. So that's good because the paddle's y represents the top left corner of the object. But we also want to get the other inequality, so you got to say and, right? Not or, right? We need to say and. And ball rect dot bottom is greater than y, but now we want to compare it with the bottom of the paddle. So we say y plus paddle height. Right? So if it satisfies both of these conditions, then we know that the y position is in between the right paddle. Okay, great. Now what about the x position? Well, could we just say if, and now we're going to check the x position, if ball rect dot x is equal to x, which is the paddle's x position. Or let me see, let's see, which one is it? It's this one here. So this is the x position of the paddle, right? Can I just do that and make it bounce on the x? Ooh, let's see, am I missing? Okay, so, and then make it bounce on the x. So then I say ball underscore speed sub-0 is equal to ball underscore speed sub-0, the negative of that. So I'm going to flip it on the x-axis. is that going to work out for me? Well, let's go ahead and find out. So I'll run it. It does not. Okay, so if I go ahead and take out this condition and see if the first condition, checking the Y position of the ball, is working, let's go ahead and run that. Ooh, that's not working out either. So let's say if the ball dot top is less than Y, yes, and ball rect is greater than Y plus paddle height. Ooh, this one should be less than, I'm sorry. And then ball top is greater than Y. Yeah, I'm sorry. So I got mixed up, right? So those are the inequalities, and so that's saying if the top of the ball is below the top of the paddle, and if the bottom of the ball is above the bottom of the paddle. So let's go ahead and run that, test that, see if it works. So it bounces when the ball is in between, is in the Y, in between the top of the paddle and the bottom of the paddle. Do you see that? But it's not working well because we also need to check the X. And so the reason why this condition here does not work if the ball's X is equal to the paddle's X position, it's because of this. So let's assume that this here is our paddle, and he's at X position of 500. And then we have our ball coming around the screen. So let's go ahead and get one of these. So then the ball is coming on down. So it's at 400. Let's say it's at 480. And then our speed is at 10, right? So it's 480, 490. Oh, no. That's bad. That's a bad example. So let's say it's at 485, right? So it's at 485, 495, 505. So do you see how the ball skips over the X position of the paddle? So since it does that, it's very rare to be in the case where the X position of the ball is going to be equal to the X position of the paddle. So how do we fix this issue? Well, you could think to yourself and just say, well, what about if the X position of the ball is greater than the X position of the paddle? So then that takes into account all of this space here, right? So if the ball is in all of this space here and in between the top of the paddle and the bottom of the paddle, then bounce. Well, that seems good, and it would make the ball bounce off of the paddle, right? But it wouldn't work in this case. The ball's coming down off the top from behind, and now it is between the top of the paddle and the bottom of the paddle, and it is also less than 500, the X position of the paddle. So then it will bounce, right? And it will continue bouncing because it's going to satisfy all of those conditions as it moves on down the paddle. So if you say X position of the ball is less than the X position of the paddle, and the Y position is in between the paddles, that will not work, because if it comes behind the paddle, it'll cause errors, it'll cause bugs, right? So how do we fix this problem? Well, what we need to do is we need to check if the Y position is between the top and the bottom of the paddle, and the X position is within a range. So it's within. So since our speed is 10, right? So the ball is going to be moving down 10 and over 10. So the most that it can move on the x-axis is 10. So what we can do is we could check if the ball is between the top of the paddle and the bottom of the paddle. We have that done. And that the ball's x position is between 500, or the x position of the paddle, minus 5 and plus 5. Right? So if it satisfies all of those conditions, that means the ball is somewhere in this box. Okay? And so if the ball is somewhere in this box, change the x direction of the paddle, and we will bounce. Boom. Boom. Right? And that's going to work. So let's go ahead and go back and code it. So we have this. Let's go ahead and adjust our inner condition. The outer condition, again, checks if the ball is between the top of the paddle and the bottom of the paddle. Now we're checking if it is in between the bottom of the paddle and the top of the paddle. Is the x position in between that right range? So I'm going to say if it's greater than, and this is the x position of the paddle, on your programs, this value should be a variable, right? But I'm just going to do it this way because this is how the state of my program. So if it is greater than this value, and I'm going to say this value minus 5, right? And I'm going to go ahead and copy this, and I'm going to paste it over here. And this time I'm going to say plus 5. So greater than the x position of the paddle minus 5, that is this end here, right? X position of the paddle minus 5, and x position of the paddle plus 5 here. So that should work. Maybe I need to change up the inequalities. Greater than this one and less than this one. Okay, so now let's go ahead and see if this works. Why is this not working out? Equals negative ball speed sub 0. So I think I'm missing a parentheses. Is that going to work out? I think I'm missing one here too. Okay, there we go. So now I have the parentheses all ready to go, and let's go ahead and run the program. Ooh, that didn't work. So there we go, bounced off the paddle. Let's try it one more time. Ooh, so that caught off the top of the paddle. So you might need to go back and fine tune and adjust the ranges. But you see that, how it bounced off the paddle? And you might think, oh no, it's just bouncing off the wall. So let's go ahead and remove the condition that bounces off the left and right wall. And let's run it again. Ooh, that did not work. So there we go, bounced off the paddle.